Ever stored prices using float in your database? You might be bleeding money, literally. In 1983, the Vancouver Stock Exchange made what seemed to be a harmless decision. They used a floating point number to track their index value. Every time a stock was added or removed, a tiny rounding error would occur. Harmless, right? Except those tiny errors added up real fast. Within 2 years, their index had mysteriously dropped over 40%. Investors panicked. The exchange had to reset the index to rebuild the trust, all because of a bad choice in how numbers are stored. In this video, we'll break down when to use int, decimal, or float in your database, and why wrong choice can corrupt your data, hurt performance, or cost real money. Let's get started. Imagine that you are working towards designing a database for an online store named the Sci-Fi Collective, and have identified all their entities, attributes, and the primary keys. Your next step is to select the right data type for each column. To do this task right, you need to pick up some knowledge about data types first. And you will start with the numeric data types in this video. The most commonly used numeric data types fall into 3 baskets: whole numbers, floating point numbers, and fixed point numbers. Let's look at the whole numbers first. A whole number is simply an integer. It may or may not allow negative values. If negative values are allowed, we call it a signed integer, otherwise it is unsigned. There are 4 types of whole numbers that belong to different ranges, like tinyInt, which has the smallest range, or BIGINT, which has the biggest range. Each of them could be signed or unsigned. Int is simply the one type that's used most frequently and good for most cases when whole numbers are needed. I have listed the ranges of each type of whole numbers here, signed and unsigned. But don't ever try to memorize them, because it's pointless. If you ever need to know the range, you could rely on the help from generative AI tools. This is a perfect use case of ChatGPT considering how simple the question is. So when should you consider using whole numbers as a data type of some attributes? When you have some actual values where possible computation or calculation would be performed on them, and they can't be fractional. For example, here's an entity that represents product reviews from the Sci-Fi Collective database. Its review ID attribute is a surrogate key, and its data are all auto-incrementing integers. So we can declare its data type as integer, and place int by its right side in the review entity representation. For another example, the purchase table from the Sci-Fi Collective database, its purchase ID attribute is also a surrogate key that contains auto-incrementing integers. Additionally, the product quantity attribute also only contains integers. As a result, you can declare the data types of both attributes as integer and place int by the right side of the 2 attributes. The use case of whole numbers is relatively straightforward. Let's move to floating point numbers. So what are floating point numbers? They are decimals that can tolerate some level of approximation. Before we get to discussing what it means by that, we need to be sure that we are on the same page on terms that are used to describe accuracy. Precision and scale. Precision means the number of digits in a decimal. Scale means the number of digits after the decimal point. In combination, the 2 terms, precision and scale, are used to describe how accurate a decimal number is. Now we are on the same page on terms. Let's get back to our discussion. So there are 2 commonly used floating number data types, including float and double. Float numbers all have a fixed data size as 32 bits, or say 4 bytes. Doubles all have a fixed data size as 64 bits, or say 8 bytes. Because of the size difference, they have different accuracy. Float can guarantee about 7 significant digits of precision, while double can guarantee about 15 to 17 significant digits of precision. So, what would be a good use case to assign floating point numbers as a data type for an attribute? When you have an attribute that stores decimal data that can tolerate some level of inaccuracy, such as sensor reading or scientific data. For example, think about when you are designing a database for a GPS tracker application, and there's a table named user location in the database. This table needs to store users' current latitude, longitude, and altitude to pinpoint users' location. Such data are decimals, and all have about 7 digits after the decimal point. Can such data tolerate some level of inaccuracies? Yes. Would float be a good fit? No. Float can only guarantee the precision of about 7 significant digits of precision. A piece of latitude data has over 7 digits alone after its decimal point. If you make its data type as float, your database can have a location error of over 10 meters, making the application useless for navigation or tracking. To account for the required accuracy, you have to use double. Double can guarantee about 15 to 17 significant digits of precision, and it's good enough for GPS data. Now, you know when you should consider floating point numbers as data types, and how to decide between float and double. Let's move to talk about when you shouldn't consider floating point numbers. Remember the Vancouver Stock Exchange. Their choice of using floating point numbers to track their index value can't guarantee the accuracy that's required, which leads to the accumulation of errors and a big disaster. As another example, if you use floating point numbers to handle currency exchange, it will lead to someone getting more or less than they should because of the random errors. So, whenever your data demands full accuracy, you shouldn't consider floating point numbers at all. Such a job is for a different data type, known as fixed point numbers. In short, fixed point numbers are exact decimals for precise values that require full accuracy. Remember the terms precision and scale? They are used to define fixed point number data types. The example that you see here on the screen, decimal 6, 4, defines the data type for an attribute. Its precision is 6, and the scale is 4, and it guarantees exact accuracy for numbers with the same precision and scale. To define the data type of an attribute as fixed point numbers, or say decimal, you need to specify the precision and scale. The keyword numeric and decimal are basically the same and can be used interchangeably. So, when do you need to use decimal as the data type for some columns? When you need to store numbers exactly as you define them, down to the right numbers of decimal places. For example, the product table in the Sci-Fi Collective database has 2 attributes that deal with money, the price and cost attributes, and they require full accuracy. If all products are sold at a price lower than $100,000, you can safely declare them as decimal whose precision is 7 and scale is 2. Now you know when fixed point numbers should be considered. As curious as you are, you may wonder, when double is a good fit as a data type, whether decimal could do the job as well. Because if you can use decimal, you can make it simple. Everything would be decimal, right? Well, let's revisit the database supporting a GPS tracker application. Can we declare their data type all as decimal 10.8? For the attributes longitude, altitude, and latitude. Well, 10.8 may have the exact accuracy that is needed. However, when double is good enough, you shouldn't really think about decimal. A double data type would mean that all the data in that corresponding column will have uniform length and would run much faster than data in a column whose data type is decimal. Such a decision has nothing to do with whether decimal would work or not. It will work, but it won't be as efficient as double. In this video, we covered the common numeric data types and discussed when they should be used as a data type for different attributes. If you find this video helpful, give it a thumbs up, subscribe, and leave your questions in the comments. I would love to hear what's working for you and what needs to change. This video is based on the book Grokking Relational Database Design, which dives deeper into database design using real-world examples to explain the concepts. You'll find the link to the book in the first comment.